Hey, Pedro. Just wondering how many people we're going to have in class. Oh, that reminds me. Thank you. Why isn't it responding? Pedro, do you know where everybody else? Oh, there's somebody else. Okay. You do it this way then.
Sir,
Yes.
my phone's gonna die and my laptop's dead. I have no internet.
Say again.
Huh?
Pedro, I'm not hearing what you're saying.
My phone's gonna die and my laptop is dead. I have no way of charging it.
Can you type into chat what you're saying, because the audio is messed up. The audio is not coming across clear. Question I have is, how many people are going to show up today? How many people are testing? Oh, your phone is going to die and your laptop is dead. If nobody shows up, I mean, if this is it for the class, my 10 o'clock class I canceled because there was only one person who showed up out of 23 people. So if there's only you two out of 18, then I'm going to cancel class for today as well from here. So it just depends upon how many people are testing. And if over half the people are testing, then I'm gonna cancel class. So unless, or I'll just have this be a study session where I'll answer questions. And Pedro, if you disappear, you disappear. Okay, I understand. Those things happen. Oh, PowerPoint thought I wanted to insert a video. I did not wish to insert a video. I wanted to insert text. Oh, I know what happened. I got two keyboards in front of me, one for my laptop and one for the classroom computer. And we have another person. I'm not trying to insert the video. All right. Please put your name in the chat. I'm having some issues with PowerPoint. I'm trying to insert something into PowerPoint and it thinks I'm trying to insert a video. Come on. I'm just trying to copy and paste text. This is what I'm doing. Let me do it this way. Yes, there it is. I don't need a tutorial. Thank you very much. Now maybe it'll let me put this in there. So we're going to have class. Okay, good. Just wait for a few more people to show up. What's wrong thing? All right, it's not letting me do what I want to do to the picture. Oh, there it goes. Okay, that's good. On the test for polynomial functions, you will have one problem. And you'll be given a polynomial function for which you will answer these things. So 10 things you're asked to do. This last one here, sketch the graph, you'll do and plot the points. You're doing as you're doing these other things. And plotting the points you do as you find them. So letter I should just give me a gimme, because you should be doing those as you're finding. You find the x-intercepts. You list all the zeros, you list all the x-intercepts, you list the y-intercept, and so you can plot those points as you find them. List other appropriate points and you plot those as you find them. And so you've done letter I while doing these two. Well, these three. And if you find the zeros of the function, you found the x-intercept. But I list it separately. So if you got them all here, you should have them all here. So this should be uniform. And then the linear factors, that's just writing it as x minus r sub 1 times x minus r sub 2, getting all those functions in there. One of my pins. Please be sure your name is posted in the chat and pin my screen so you can see what I have for you there. So you can read it better, so it's more visible to you. Went the wrong way with that one. That's not what I wanted to have happen. Dadgummit. Oh, don't tell me you're gonna crap out on me. All right, so we're gonna do this for a couple of polynomials. 2x, I walk away and I forget everything about it. 2x cubed minus 11 squared, 11x squared. I didn't look beyond that. I trip and almost fall and break my face. Plus 12x plus 9. Plus 12x plus 9. And this is f of x. And so we're going to do all of these things. I said there's 10 of them, right? 1, 2, 3, 4, 5, 6, 7. First thing is to do is to describe the end behavior. You describe the end behavior by looking at the leading term. And looking at the leading term, we notice that it's x cubed, it has an odd degree, and the leading coefficient is 2, and 2 is greater than 0. So since it's an odd degree, they're going to be, the end behaviors are going in opposite directions. Okay, since it's since the leading coefficient is greater than 2, that means it's going to go down to the left and up to the right. So for letter A, sorry. For letter A, it's going down to the left and up to the right. So you can use the arrows, or you can say, or you can use the words down to the left and up to the right. Or you can say as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. So you, I've given you 3 ways to represent this. And the next one is to list all the possible rational zeros. Well, I'm going to look at, so 9 gives me my p values, and 2 gives me my q values for p over q. So the factors of 9 plus or minus 1, plus or minus 2, plus or minus 3. No, not plus or minus 2. I don't know why I did that. Actually, I just wasn't thinking, I was just counting. Plus or minus 1, plus or minus 3, plus or minus 9. And then Q are the factors of positive 2, which are plus or minus 1, plus or minus 2. So I'm going to divide each of these numbers here by each of these numbers here. And so I'm going to divide 1, 3, and 9 by 1, which is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 9. And then I'm going to divide each one of these by 2. So now I have plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. So these are so this would be letter B. Descartes' rule of signs. Now, well, I'm going to need F, and I'm going to need F of negative X to determine how many positive and how many negative real zeros I could have. And it should say real zeros here. I did an omission on my part. And so if it has an odd degree, I'm going to change its sign. So this is going to be a negative 2x to the third minus 11x squared minus 12x plus 9. The constant never changes. X squared, the sign won't change on that, but on x cubed and x, the sign will change. And now I go through and count some sign changes. Here I have one sign change, and here I have another sign change. So for letter, this is letter C, I have 2 sign changes.
Quick question, seeing as this is f of negative x, wouldn't it be 11 squared, not negative 11 squared?
Say again?
For f of negative x, wouldn't that be 11 squared instead of negative 11 squared?
Well, this negative sign here won't be effective.
If it goes over to f of negative x?
Yeah, what happens? That's a negative x being squared. So
Oh, yeah, that's right. Okay, thank you. I forgot about that. Okay, I wasn't thinking. Thank you.
Oh, ask questions. That way things get clear. Try and make sure I'm still on the screen. And I am not. So this is letter C, right? Letter C. For the number of positive, it's going to be 2 or no positive real zeros. So if I have a positive real zero, I will have 2 of them. And that's from f of x. And from f of negative x, I have exactly 1 sign change. So that means I am going to have one negative real zero. So the number of zeros we're going to have here is either I'm going to have 1 0 or I'm going to have 3 zeros. The maximum number of zeros I can have is 3. And this covers it. I either have 2 and 1 or I have none and 1. Right? 2 positive, 1 negative, or no positive, 1 negative. So that means I'll either have 3 or 1 real zeros. And now we start finding the zeros. Now, I used to have another letter in here, another one in here, which was to check for -1 and 1 as zeros. And that's quite easy. All you need to do is add the coefficients of f of x, and if they add to 0, then that means 1 is a 0 on the function. And if I look at the negative f of -x and add those coefficients together, and if they add to 0, then -1 is a 0. Well, as you can tell, here I'm going to get what? I'm going to get adding 2 minus 11 plus 12 plus 9 is going to give me 12. Oh, not 12. Yeah, it'll give me 12. Because 2 plus 9 is 11, and 11 minus 11 is 0, and then I'm still adding the 12. So that means the point 112 is on that line. So I found the point for number 8, for letter H. And putting negative in for x, well, and I add these coefficients together, so that's going to be a -13, a -25, so that'll give me a -16. So when I put -1 in, I get a -16. Okay. So now I found 2 more points, so I can ignore checking -1 and 1. So I'm going to start by checking +3. Or maybe I should start with negative. But it doesn't matter. All right, I'm done using this. Everything else is done using f of x. The only reason we use f of -x is for Descartes' rule of signs and checking if -1 is a real 0. And so the rest of this, we're looking at that. So to find these zeros, and as you find the zeros, you're finding the linear factors and you're finding the x-intercepts. So these 3 together you're doing all 3 of them at the same time. So
Sir, I have a question.
Yes.
So for to check the -1 of x, can we use f of x, or do we have to use f of -x?
You can put -1 in for x.
Okay.
To check for it. But if I put -1 in for x here, I get a -2. If I put -1 in for x here, I get -11. If I put -1 in for x here, I get a -12. And the constant stays the constant. So I still get those coefficients. That making sense?
Okay. Yes.
But which is why once you write this, then it's those are the numbers you're going to get when you put -1 in for x here. You're going to get these coefficients. But
Okay.
Do it the way it makes sense to you. Okay? If you don't want to
Okay.
remember the fact, you don't have to remember that. But it's quite easy to determine if -1 or 1 is a 0. And the rest of it, I use synthetic division. Rather than putting 3 in for x and finding out what that equals, I'm going to do synthetic division. So I'm going to do 3 And my coefficients are 2, -11, +12, and 9. I bet -3 will work, and 3 doesn't. So I'm going to bring down the 2, multiply by 3, which gives me 6. Combined, that gives me a negative, what, 5? Oh, 3 is going to be a 0. I can see it already. 3 times 2 is 6, and 6 and -11 is a -5. 3 times -5 is a -15. -15 and 12 make for -3. And -3 times, 3 times -3 is a -9. So boom, I found a positive real zero. So that means I'm going to have another positive real zero. And I'm still going to be looking for that negative. But this factors this quite nicely. So here I have one of my zeros is 3, and I have factored this to x minus 3, right? If 3 is a 0, then x minus that number is a factor. And this is the first depressed equation. 2x squared minus 5x minus 3. Oh, that's going to be easy. Because I can factor this using guess and check. Trial and error. Run madly crazy infinitely. Okay. So, and then I just have x plus 3. X. What's that? X minus 3 here. And so I can factor this into 2 nice polynomials. And I've been kind of doing it in my head while I've been talking here. I'm going to have, because my factors of 2 are 2 and 1, so I'm going to have 2x and x, because 2x times x is squared. And now I have factors of 3. Well, I'm going to see if I have a 3 here and a 1 here. And one of them has to be negative. Is that going to work? I don't think that factors nicely. Well, the factors of 6 that subtract to 5. Oh. It's going to work this way though, with the 3 being minus and that being plus. Because now 3 times 2 is a negative 6x, and 1 times x is x. When I combine them, I get a negative 5x, which is what I needed there. So there I factored it. Now look at that. 3 is a double root. So that means I have x minus 3 squared times 2x plus 1. So my 2 zeros, my 2 real zeros are the same number. But they show up twice. That number shows up twice. So it has a multiplicity of 2. So I'm going to put 3 and state the multiplicity. So it's multiplicity. Multiplicity 2. And so all I need to do is find out that what makes this one 0. And this one's going to be my negative real 0. And this is going to be a negative 1/2, which is one of my choices here. Because I have 2x plus 1 equals to 0. We subtract 1 from both sides, so we get 2x equals a negative 1. And then divide through by 2, and we get x equals a negative 1/2. So here I have -1/2. And that has a multiplicity. Multiplicity. 1. And usually if we have multiplicity of 1, we don't mention it. But I'm just doing it because people do. Right. So, wow. This is letter E right here. That was letter D, listing the x-intercepts. Well, there they are. 3, 0, and -1/2, 0. Or I could just list the 3 and the -1/2. And then the y, what's the y-intercept? What's the y-intercept of polynomials?
9.
Yeah. The constant so that you can find without doing anything. You just look at the equation, look for the constant. So the y-intercept, you can either just put the number 9 or you can list the point 0.9. Either way is acceptable in my eyes. Now, at this point, before we start finding other points other than these two, we want to look at where they are on the graph. So my y scale is going to be very severe. It's going to be way squished down because we have a -16. All right, so I have +3 over here. 1, 2, 3. And -1/2 over here. And at 0, when x is 0, it's at 9. So I'm going to say this is 5, this is 10, and this is 15, and that's 20. So we have -5, -10, -15, and -20. Now, 112 is going to be about here. So 112 is approximately here. -1, -16 is down here. Right. Now, looking at the end behaviors, this data seems to fit it because this is my lowest x-intercept. So as x goes this way, it's going down. And that fits the data I found there. And at 3, it's going to be going up from there. And since 3 has a multiplicity of 2, that means it's going to come down from up there and bounce. And then I haven't plotted 0, 9 yet. That's here. So there's two more points I want to find. I want to find out at -2 simply so I can refine what's going on inside here and see how close to this point the relative maximum is. And then I want to find out at 4 to see how fast it's jumping. So I'm going to do synthetic division, and I'm going to use the remainder theorem. That means if I do synthetic division here, the remainder is f of that number. F of 3 is 0. So I want to find out what f of 2 is and f of 3. So I'm going to erase my work here. Hopefully you have it down already. And so I'm gonna do 2 into the 2, negative 11, 12, and 9. And so I bring down the 2, multiply 2 by 2, that gives me 4, that gives me a negative 7 here. 2 times a negative 7 is a negative 14, and that'll give me another negative 2 here. And 2 times negative 2 is 4, negative 4, and so that'll give me a 5 here. That's why I wrote 5. Is 5. So that gives me the point 2, 5. There's another additional point. So at 2, it's up here at 5. So inside here, it's going to be going up, and then it's going to start curving around, and then diving back down again. And so that means, that probably means our relative maximum is going to be between 1 and 0 and 1. When x is between 0 and 1, we're going to have our relative maximum. I don't necessarily need to find it, but that gives me an idea of what's going on. I can put 1/2. I can find out what happens with 1/2, and that'll get me even closer. But and so now I want to do 4. And so all these numbers, except for the beginning 2, is going to change. And 4 times 2 is 8. And negative 11 plus 8 is a negative 3. 4 times negative 3 is a negative 12. 12 minus 12 is 0. 4 times 0 is 0. And 9 plus 0 is 9. So when it's 4, it's up here at 9. So at 4, it's the same level as the x-intercept, I mean the y-intercept. So it's not going up as quickly as it goes down on this side. And the reason for this being steeper over here than this is, not by much, but it is much steeper, is the 11x squared. Because I'm subtracting it out. And when x is negative, these 3 things are negative. So it's just boom, dropping like a stone. But over on this side, these 3 things are positive, and this one is negative. So, and it's a large negative, so it's not going to grow as fast. And we're done. How long that take? And that's why I only have one of these on the test, because it takes a lot. But I erased letter C, letter E I erased. So E was, if I remember correctly, was x minus 3 being squared times 2x plus 1, right? Letter E. And I should write this as f of x equals. Because I factored the function to that. Any questions? Now, what I'm going to put in what do we call that? Canvas. In the files under Canvas, you will get something that has, well, let me show it. Uh-oh. I didn't copy it. I totally erased it. 1 second here. Need to make it smaller. There we go. Where's the zoom? There's the zoom. And share this. Okay. Uh-oh. It's not showing my share screen. It doesn't look like. Or was it? Oh, I can't. I don't
It was.
It was? Okay, so that's.
Not anymore, but yeah, it was.
Yeah. I forgot. I haven't used the share screen in so long that I've forgotten what it does. My screen doesn't change. So this is still there. And the only difference, the only thing I would add here, letter D would be check for -1 and 1 as zeros. And all of this, then this would become E, F, G, H, I, J, and K. One, two, three, four, five, 7, 8, 9, 10, 11. So there'd be 11 things to do. Granted, 3 of them, you're doing at the same time. As you're finding the zeros, you're finding the linear factors. And as you find the zeros, you have found the x-intercepts. And then the y-intercept is just what is the constant. And then the last two, well, you plot all those points you find. And then, well, before you do H, well, or 4 was what? 4 was 9, right? So we found all those points. Once you plotted the x-intercepts and the y-intercept, then you start adding, and if you found points for 1 and -1, plot all those points, and then you find other points to refine your graph. You want to see how quickly it's plummeting or rising. And if it's an even function, then I want to find out both how fast it's going. And then I find out in the middle what's happening. So I want to see much more refined here. So I'm going to see what 1/2 does. Because I just want to find out. So, and I'm going to do 0.5 rather than 1/2. Because 0.5 is going to be easier to use. So I bring down the 2, 1/2 of 1, 1/2 of 11, 1/2 of 2 is 1, and so that gives me a -10. 1/2 of -10 is -5, which gives me, what is that, a -7? No, a +7. And 1/2 of 7 is 7.5 or 3.5. And so that's going to be 12.5, which is not hard to graph. 12 point, this was at 12, right? And so at 1/2, it goes up to 12.5. So that is extremely close to where the local maximum is going to be. So I'm going to do some calculus here. We have 6x squared minus 22x plus 12. Dividing 2 out of that gives me 3x squared minus 11x plus 6. And this factors quite nicely to 3x plus 2. No, was it plus 2? The factors of, it's going to be minus 2. And x minus 3. Two-thirds of 0. So at 2/3 is where it's at its maximum. So the maximum is between 1/2 and 1. Yeah. Using calculus, what I did was find the first derivative, and where the first derivative equals 0, then that gives you that tells you where the tangent line and its slope is 0. And it's and that gives us a local maximum and local minimum values. Well, 2/3 is going to be at the local maximum, and 3 is at a local minimum. And we already knew that 3 was a local minimum. Cool. So if you go into calculus, you can go, oh, Mr. Reed told us that. You choose to remember. All right, any questions on this? Yeah, we got time for another one, possibly more. There's a list of 10 polynomials. We did one of them. So numbers 2 through 10, call out a number and we'll do that one. Come on. Which one do you want to do? Or we can do it together. I'll do it up here and you can do it up back. Well, I'm just going to go on do number 2, where we have x to the 4th. And I'll walk away and forget what it was. X to the 4th, 7x to the 3rd. Was it 2x? No, it was 9x and 7x. So we're going to have at most 4 zeros here. So I'm going to stop the share. Yeah. Oh, 8. Okay. Let me pull up number 8 then. Let's do that one instead. Yeah, I glanced at that one. I thought, well, that one would be interesting. And so let me change it. We'll do this one later if we have time. No, we won't have time. 3x to the third, 3, 22, 32, 32. 3. Two steps and the numbers disappear from my brain. 22. Now I just need to remember the signs. Plus, 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 minus. Plus, plus, minus. And simply because I'm going to need to use it, I'm going to go ahead and find out what f of negative x is. That's the first thing I do, because I'm going to use this later on. It's just easy to do it right away. So this is going to be a negative 3x to the third plus 22x squared minus 32x minus 32. Yeah, I'm just going to, and so now for letter A, the behaviors are just like what they were on the first problem we did, because this is a positive coefficient and it is an odd degree function. So they're going to go in opposite directions. So for letter A, it's going to go down to the left and up to the right. Listing all the possible rational zeros. Well, the factors of 32 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, and plus or minus 32. I think that's all the factors. Yeah, 32 is a binary number. It's 2 to the 5th power. That means all of its factors are going to be binary numbers. 1, 2, 4, 6, 8, 16 are the first 5 that binary numbers. And the Q values come from the leading coefficient 3. So it's going to be plus or minus 3, plus or minus 1, and plus or minus 3. So my P over Q numbers, which are my potential rational zeros, is going to be plus or minus 1. Plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32. And now I'm going to divide each one of these by 3, so I'm going to add that many more fractions. So it's going to be plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, plus or minus 16/3, plus or minus 32/3. None of these fractions reduce. If they did reduce and they reduce to a number I already have listed here, I don't write it down a second time. And I'm just writing this as a set of numbers because that's what it is. It's a set of numbers. So there are all the possible rational zeros. Okay? All the zeros? No. Now we're gonna use the card full of signs. And I already put in this in. And so, the sign changes here when, for f of x, is we only have one sign change. This is letter B. And letter C means we're gonna have one positive real zero. And f of negative x has 1, 2 sign changes. So it will have either 2 or known or no negative real zeros. So if I have a negative real zero, I'm going to have 2 of them. And I will have a positive real zero. We came across a theorem that stated if it's a third degree polynomial, if it's an odd degree polynomial, it will have at least one real zero. And it will be a positive one if there's no negatives. So it will have at least one real zero and possibly 3. Okay. Now we start finding zeros. So what I would do right here, I'm gonna put in C sub 2, which is checking for -1 and +1 as zeros. So 3 plus 22, so yeah, that's just gonna get more positive. These two go to 0, so that's gonna be 25. So we have a point 125. And putting -1 in, here I have a -64, so this brings it down to a -42, and this brings it down to a -38. So when I put -1 in, I go down to a -38. So I know 1 and -1 are not zeros. So I start with a 2. So I do synthetic division using 2. And I have 3, 22, 32, and -32. And I draw a line under here. And I bring down the 3. 2 times 3 is 6. 6 and 22 is 28. 2 times 28 is 56. When I combine those, I get 88. And 2 times 88 is 176. And 176 and -32 is 144. So 2 gives me a 144. So 2 is not a 0. Well, let's try -2. Because I bet I'm going to have a -0. Can't guarantee it, but I'm pretty sure I will. So now I'm going to do -2. And -2 times 3 is a -6. And that'll combine to give me what? 16. And -2 times 16 is a -32. And -32 is 0. And -2 times 0 is 0. And -32 and 0 is -32. So -2 gives me -32. Well, it's sucking now. Okay, so now we move on to fourth. And on your paper and doing your work, you wouldn't erase anything. You keep it all there so you can show me all your work. That's extremely important to show me all your work. I've had people who would normally have made 100, did not make 100 because they did not show all their work. So I couldn't give them all the points. I need to see how you got the answer. So 22, it looks like 2, 2. Okay, so 4 times 3 is 12. So that gives me what, 34? 4 times 34 is 136. And that gives me 168, and 4 times 1. So yeah, it's gonna get ridiculous. Well, let's try -4, see if that does any better. So that'll be a -12 here. If I need that point, I'll go back and reclaim it. And so when I combine, that gives me a -10. And -4 times -10 is a -40. And when I combine -40 with 32, that's a -8. And -4 times -8 is a +32. And that gives me a 0. All right. It took a while, but I found a 0. So D, I'm going to start listing my zeros. So -4 is one of my zeros. So that means I have factored this thing to x plus 4, right? It's x minus a -4, which is x plus 4, times 3x squared minus 10x minus 8. All right. And when we factor this, one of the factors is going to have a negative, and one of them is going to have a positive. So that means I'm going to get a negative and positive 0 there, which fits this pattern quite nicely. I'm going to end up dividing by 3, so that's going to be, one of these is going to be a fraction, and the other one won't be. So I bet it's -8. Or it might be -4 again. Yeah, let me do that. Let me try -4 again. -4 on 3, -10, and -8. See if that'll give me a 0 over here. So I bring down the 3. No, that won't. Or -4 isn't a repeating 0. But let's see if 8 is a 0. So 8 times -8 times 3. The factors of 24 that subtract the 10. So that's going to be a 3, 2, and 12. And let's just look at this. So I'm gonna use my where I have 3x and 3x. And I'm multiplying 3 times 8, which is 24, and the factors of 24 that subtract to 10. That's 2 and 10. I mean 2 and 12. Because 10 minus 2 is 10. To get a -10, the 12 needs to be negative. So it's going to be a 2 here and a 12 here, and the 12 will be negative. And because I put in an extra 3, I need to divide by 3. And 3 will divide this one quite nicely. So yeah, 4 should have given me a 0 before. So now I
Could
have.
you use 4 and 6? Could you use 4 and 6?
6 isn't one of our potential zeros.
Oh, that's right. Okay.
Yeah. 4 should have given me a 0 over here. But it looked like 4 wasn't gonna get me there. That is interesting. No, 4 should not give us a 0. Oh, I know why. This is for. One of these is positive and the other one's negative. This one has to be positive, that one's negative. That reads correctly here. That's confusing me. Yeah, because if I did synthetic division was 4 on 3, -10, and -8, I bring down the 3, multiply by 4, which is 12. 12 minus 10 is 2. 2 times 4 times 2 is 8. And so that gives me a 0 here. So that's 3x plus 2. Yeah, that's supposed to be a plus. So how come 4 doing negative 4 times 3 is a negative 12, and that gives me, and that, oh, that's supposed to be a positive 10. That's supposed to be a positive 10. And so I'm going to switch my signs here. Minus and plus. So -4 should have worked. Yeah. Because if with that being a positive, then that'd be a -2 here. -12 and a -2. No, that wouldn't have worked out. Oh, because this would have been negative. So negative times negative is positive. So, okay. So -4 is a repeating 0. Because now I have x plus 4 times 3x minus 2 times x plus 4 again. And then setting 3x plus 2 minus 2 equal to 0 gives me 3x equals 2, or x equals 2/3. 2/3 is one of my numbers here. -4 is one of my numbers here. And so this one has a multiplicity of 2. Or I learned I've been saying that incorrectly all these years. Multiplicity, it's multiplicity 2. And 2/3 is multiplicity 1, but we don't need to. We don't. So I look at where those points are on the graph. So at -4, we have a 0. And since it has double multiplicity, it's gonna touch like this. No, it's not gonna touch like that. Because as x is going negative, the y values are going down. So it's going to come up here and bounce back down. It's going to cross the y-axis at -32 down here. And that's after it's coming back up because it's gonna cross the x-axis. Put -4 down. So it comes up like this. Yeah, and its local minimum is gonna be down in here somewhere. And so I would check out -2 to see how far down it goes. Did we find out -2? -2 went down to 32. To -32. So it went down here. So it even went down even further than that. Because now I know it's going to go like this. So at -1, it went down to -38 down here. So it went down like that and then came back up. And it goes through 2/3 up here. And I know at 1, it's at 25 up here. And so it'll go through this point here. And at 2, it goes through 144. So it just explodes upwards. And I could, and then I would look at what happens at -5, simply to see, is it exploding downward the same way it's exploding upwards? Or is it going faster down? So doing synthetic division with -5, -5 gives me 3, 22, 32, and -32. So that's going to be a 3 here or -15 here, which is going to be, what the hell is that? 7? And so this is going to be a -35. And so that'll be, whoa, that's not right. -5. It's going to be positive. It can't be -5. It has to be negative. Oh, I see what I'm doing here. Okay, so 32 and a -35 is a -3, and so that'll give me a +15. And when those are combined, that gives me a -27. So at -5, it's down here at -27. Put -27 there. This is not to any recognizable scale. Okay. You can adjust your scale by deciding what each tick mark equals on your graph, group of tick marks. In this case, on a normal one, since I want to go down at least to 38, I'd go down to 40, and so I had each tick mark either be worth 4 or 5. So if that was each tick mark being 4, then it would go down to 10 tick marks and go up 10 tick marks. And I would keep this being each tick mark being 1 for my x-axis. And now I'm done. So the 2 other appropriate points I found, -5, it went to -27. And did I find another one? Yeah, no, -1, I found it was here. -2, I found. Well, we already found -2. I could find at -3, but I don't see a point behind doing that. Finding what happened at -1. The local max minimum here is going to be very close to this point. And the local maximum here is -40. Questions? Yeah, keeping track of the signs here is very important. As you notice, I screwed up with the signs. And I multiplied -4 times a -10 and got a -40, which was, would have been correct if I had the correct sign on the 10. Okay. And what else? I'm going to go ahead and do that number 2 because we have plenty of time here. And I'm not going to try and keep all the answers up here because there's going to be a fair amount of work. Because we're needing to find up to 4 zeros. Because the is to the 4th degree. So that was 7, 9, 7, 10. X to the 4th, X to the 3rd, X squared, X. I just need to remember the signs, which is negative, minus, plus, plus, minus. Minus, plus, minus. X to the 4th is an even degree function. That means both end behaviors are going the same direction. And because the leading coefficient is positive for letter A, they're both going in the same direction. Listing all the possible rational zeros, we have 10 and 1. So my p-values come from the factors of 10, which is plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And my leading coefficient is 1. So my factors for my q numbers are plus or minus 1. So all my possible rational zeros are the factors. So letter B is plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And so there's my potential zeros. And now for letter C is using Descartes' rule of signs. So now I'm going to find f of negative x. F of negative x. If it has an odd degree, the sign will not change. If it has an even degree, it won't change. If it has an odd degree, the sign will change. So even degrees will not change, and the odd degrees, the sign will change. And the constant is a constant for a reason. Now we count sign changes. For the number of positives, so the positive real zeros, I have 1, 2 sign changes. So 2 or none. And now for the negative real zeros, I look at my sign changes here and I have, whoa,
There's 3 sign changes for the positive.
yes, thank you. I just realized my mistake. Because the maximum number of sign changes need to add up to 4. And I was just gonna get 3, so that means I screwed up on my positive. So I had 1, 2, 3 sign changes, so that's 3 or 1. So I will definitely have a positive real 0. And if it's just 1, I bet it's a repeating ones show up separately. Okay, and so there'd just be one negative. So the number of real zeros I'll have are either 4 or 2. Because adding the negative to the positive, you get 4 in this case and 2 in that case. And if there's only 2 here, then that means the number of complex zeros, because the number of zeros need to be 4. So the number of real zeros plus the number of complex zeros need to equal 4. Now let's see. Let's start finding zeros. So the coefficients, because I'm going to use that. Well, right here there would be another one about checking for -1 and 1 for 0. So I had 1 minus 7 plus 9 plus 7 minus 10. Well, that's not going to be a 0, and neither is this one. So that's a -6. 3, 10. Oh, that is 0. So 1 is a 0. 1 is a 0. So I have 1. That means that's going to be 1, 0 is an x-intercept, and x minus 1 is a factor. Now for -1, 1 plus 7 is 8, 8 plus 9 is 17, minus 7 is 10, 10 minus 10. Oh, -1 is a 0. -1 and 1 are zeros. And so -1 here, so that's going to be x plus 1. And that's going to be -1, 0. The y-intercept I can list right now, it's 0, -10. Now, what I'll do is I'll do synthetic division. I'll use 1, and then I'll use -1 to find the second depressed equation. And so my coefficients are 1, -7, 9, 7, and -10. And so I know 1 is a factor, so I bring down the 1. And that 1 times 1 is 1, so that's -6. 1 times -6 is -6. That's going to give me 3. 1 times 3 is 3. And that gives me 10. 1 times 10 is 10, and that gives me 0, which I knew was going to happen. Now, if it's a 0 that I haven't divided out yet, of the function, then it's gonna be a 0 of the crest equation. So I'm gonna use -1 here and get a second depressed function. And so I'm gonna bring down that 1, multiply by -1. That gives me a -7, multiplied by -1, which is +7. Combining gives me a +10, and then multiplying 10 by a -1 gives me a -10, which gives me 0 here. Which is tremendous. So now I have x minus 1 times x plus 1 times x to the third x squared, sorry, x squared minus 7x plus 10. And this is a quadratic that factors twice quite nicely. The factors of 10 that add to 7, well, that's 2 and 5. And they both need to be negative, so when I add them, I get a -7. So I have x minus 2 times x minus 5, right? So now I have factored it completely. So I'm going to add those two factors here, x minus 2 and x minus 1. I have 3 negative zeros and 1 positive zero. 3 positive zeros, 3 positive and 1 negative. Because now I need to set both of these equal to 0, x minus 2 equals 0, x minus 5 equal to 0, and this one gives me x equals 2, and this one gives me x equals 5. And so those are 2 more of my zeros, 2 and 5, and 2 more of my x-intercepts, 2, 0, and 5, 0. The only thing I haven't done yet so far is to find other appropriate points. So, all right, that left me room over here to do a decent graph, or a somewhat decent graph. And so my zeros go from -1 up to +5. So -1, 1, 2, 3, 4, and 5. You know what -1 crosses? At +1 it crosses, because all of these have multiplicity 1. Right? All the zeros have a multiplicity of 1, so we don't worry about listing the, or you can just say they all have a multiplicity of 1. What was the other one? 2 and 5. And at 1, it comes down, I'm going to put -10. So that means this is going to be -20 now. So this will be 10 up here and 20 up here. I don't know if that's going to be okay. I may need to squinch it down even further. But I know because the end behaviors, they both go up, that means it's going to be going up from -1. I want to find out what happens at 2. And that means at 5, it's going to be going up from -5. So I want to find out, +5. So I want to find out what happens at 6. I don't necessarily need to find out what happens between 2 points. between -1 and 1. But I do want to know what happens at 1.5. And just for grins, I'm going to put 3 and 4. I'm going to find out those. So I want to find f of 1.5, f of 3, f of 4, f of 6, and f of -2. So I'm going to do synthetic division for those 5 more points. I can just use a calculator. But I like playing with numbers. No, everyone, no duh, Mr. Lee. So I'm going to do -2 first. So that gives me a -2 here, which gives me a -9. So that gives me a +18, which is 27, which gives me a -54. And so this will be a -47. And that'll give me a +94, which is a +84. So over here, it just really explodes, and I'm not going to worry about putting that point on there. But I'm going to list it as one of my points, -284. And now I'm going to use 1.5, 1.5, or if I did the fraction 3/2. No, we'll do 1.5. I have 1, -7, 9, 7, and -10. So that gives me a 1. So that's going to be 1.5, which is a -5.5. And 1.5 times 5.5, that's why we have calculators. Or 3.5 times a -21 halves, which is a -63/4.
-8.25.
What'd you say? -8.25?
Yes.
Okay. I'm not sure about that point. Okay. And so it's going to be 11. That's 11 halves. Okay. And that gives me 0.75. And then 0.5 times that gives me 1.1.
$1.125.
1.25.
125.
Oh, 1.125.
Yes.
Okay. And that gives me 8.125. And that'll give me what, 9 or 10 point something? So it's going to be 8.125 plus 4. So that's going to be 12 something. After that is 0.625. And so that's going to be 12.1875. So 12.818. Did I get it right?
Yes.
Okay, so when I combine those, my remainder is 2.1875, which is close enough to 2.2. So I think this is 1/16, but I'm not 100% sure. No, that's not 1/16. Is that 3/16? That might be 3/16 or something like that. And so 1.5 gives us 2.1875, and when I graph it, I'm going to use this. So at 1.5, it is just barely above here because this will be 1, that will be 2. So it'll be right about there. And so it comes down here like this, missed this, and comes up, and then just like that. And so at 3, we get a 3 here, and that'll be a -4, and that'll be a -12, which will be a -3, which will be a -9, which is a -2, which is going to be a -6 or -16. So at 3, it comes down to -16, which is about here. And then at 4, that's going to be a 4 here and a -3, and that's going to give me a -12 and a -3. And that'll give me another -12 here, which gives me a -5, which will give me a -20, so -30. So 3 gave me a -16, and 4 gave me a -30. Can I do that right? So I'll give me a -3 again. So I'll be in a -12 again. Yeah, okay. So -30 is going to be way down here somewhere. And so, yeah, so it drives downward, and the local minimum here is going to be to the left of this point. So it's going to go down further and then come back up like that. And so 6 is probably going to be huge. So 6 into 1, -7, 9, 7, and -10. Bring down the 6, and 6 times, bring down the 1, and 6 times 1, and that gives me a -1, so that's a -6, so that's a +3, sorry. And that'll be 18, and so that'll give me 25 here, and 6 times 25, how much is 6/4? $1.50. So that's 150, so this will be 140, which I wouldn't even try and put on, but I would put it in my list of points. So 6, it goes to 140. And there's my graph. Heads up, I will not give you a degree 4 on the test. What I will give you is a 3rd degree polynomial on the test, polynomial function on the test to graph. I'm going to post this online. I'm going to add in. This, so these letters will change. This will be E, F, G, H, I, J, K, and so I'll add a new D here. And I can do that right now, as a matter of fact. Yeah, it says check for -1 and 1 as zeros. That's what I added in. And I'm kind of worn out. It's a long morning. Any questions on any of this? I don't find this difficult. And I'm not just saying that because I love doing it. I don't see it as difficult. The difficult part is remembering what you're supposed to do. Now, the textbook would have you do things a little differently than I do, but that's a difference in style, in procedure. But the procedures all are legitimate and they get you where you need to be. So I don't know what to say here, because I'm done. And we got 5 minutes, less than 5 minutes left of class. Any questions here on any of this, these procedures? Monday, we're going to do the same thing, except with rational functions, graphing rational functions. And this is how I test on everything about polynomial functions is contained in this one question. That you use the remainder theorem. You use the factor theorem. You use those 4 things that are true about polynomial functions. If R is a 0 of the function, then x minus R is a factor, and R is an x-intercept, and f of x equals 0. It's a solution to f of x equals 0, which what we used here. We found the solution to this depressed equation is 2 and 5. And that's how we found those 2 zeros. And well, we found the linear factors first, and then we found the zeros and wrote them as x-intercepts. So we used all 4 of those statements here in this. Also in the ones that have a 3rd degree, we did the same thing. Okay. Descartes' rule of signs just informs us. It doesn't actually help us find those zeros, but it informs us about the zeros. I knew I was going to have a -0. And what was the first -0 I found? Well, no, not on this one. Well, on the previous problem. We knew we used -4 on one of the previous problems because we knew we were going to have a negative real 0. Right? And since we found that -1 was a 0, then we knew the other zeros were going to be positive. And we already knew there were going to be 3 positives because we determined 1 was going to be positive, 1 was a 0. So that means we were going to find 2 more positives. And we already found the 1 negative. And so it was just a matter of finding the problem. Because this informs us how many more zeros we're gonna need to find as we find our zero. And right now I'm just rambling, so unless you have questions for me, y'all are free to go.
Sir, are the other 7 problems from the document homework or no?
Say again?
Are the other 7 problems from the document that you're gonna post, are they homework?
They are a practice.
Okay,
So in a way, yes, they are homework. All the homework is practice. And that's where you learn how to do it. And that's what I test over. That makes sense.
yes.
And while I'm thinking about it, let me go ahead and, where is it? Oh my, I closed it. I didn't mean to close it. Oh, I saved it and it went away. Okay. So now I need to save it again. Or let me print it as a print to file.
Hey, sir.
Yes.
I need to ask you something because I went back to your YouTube channel to look back and try to review previous stuff.
Yeah,
And
they're not there yet.
Yeah, I want to know about it. Like,
Well, I've been having some issues with I was saving those videos to a thumb drive, and the thumb drives, they would show up there until I pulled the thumb drive out of the computer, and when I put it back in. So I did that 3 times so far, but now they're sticking, so I'm gonna be able to. And I was trying to do that several times. Okay. Let me see here. So, yeah. Wait a second. I need to close that down. So did that answer your question? Oh, geez.
the thing is, I was able to hardly hear you.
Oh, I had troubles downloading the videos. They weren't saving properly to my thumb drives. But I have them now, so I can go ahead and start uploading them.
Okay, cool. All right, good. Yeah, because it's been since the 27th of September. It's been a while.
No, yeah.
Yeah. Yeah, because that would really benefit me because I don't do well learning once. I need to go back because I'm not a fast learner. So that'll be really beneficial for me. All right, so good to know. Are you gonna send a notification or let us know if it's been uploaded, or do we just go to it?
I'll put an announcement in. As
All right,
soon as
cool.
I get them all uploaded, I'll put an announcement.
All right, cool. Thank you so much, sir.
Sure.
That's pretty much it. Have a good day.
All right. Take care. I'm left all alone in here.